Ever wondered how atoms stick together to form everything around us? Picture a world where tiny building blocks connect to create everything you see, feel, and use. Today, we explore the fascinating forces called chemical bonds that hold atoms together. Chemical bonds are the forces that hold atoms together in molecules and compounds, formed when atoms share or transfer electrons to reach stability. This idea might seem abstract, but it's a key principle that explains the structure of matter. Imagine the atom as a miniature solar system. In this system, electrons orbit the nucleus like planets around a sun. These electrons are eager to reach a stable configuration, much like you try to feel secure at home. When atoms meet, their electrons interact in ways that either share control or exchange partners, leading to different types of bonds. The challenge is to understand how these interactions work, but by relating them to everyday experiences, the picture becomes clearer. Let's begin with ionic bonds. Ionic bonds occur when electrons move from one atom to another. This transfer creates ions, charged particles that attract each other. Think of ionic bonds like magnets where opposite charges pull together with a strong force. For example, imagine one atom as having an extra electron and another lacking one. That discrepancy creates a push and pull path, much like the magnetic attraction of opposite poles. This strong attraction is why ionic compounds often have high melting and boiling points. It's a dynamic dance of electrons that gives structure to substances we encounter daily. Next, we look at covalent bonds. Unlike the complete transfer of electrons seen in ionic bonds, covalent bonds involve sharing electrons. Picture a handshake between atoms where they join together by sharing what they have. This sharing helps each atom feel complete and balanced, much like friends teaming up to achieve a common goal. Covalent compounds typically have lower melting and boiling points compared to ionic compounds, and they do not conduct electricity. This difference arises because the shared electrons create a stable but less rigid connection between the atoms. Another fascinating type is the metallic bond. In metallic bonds, imagine a sea of electrons that flows around a lattice of positively charged metal ions. This sea of electrons allows the metal to be both conductive and malleable, meaning it can bend without breaking. Think of it as a fluid network where the electrons are free to move and carry energy, giving metals their unique properties. This dynamic behavior is what makes metals such useful materials in everyday life. Throughout our journey, remember that the structure of atoms and the behavior of electrons are at the heart of how chemical bonds form. The bonds determine not just the stability of matter, but also the physical properties we observe, from the crisp structure of a salt crystal to the flexible nature of metallic objects. By understanding these concepts, you unlock the secrets behind the composition of our material world. As we delve deeper into each bond type, consider how nature uses these principles to build everything around us. Whether you're mixing ingredients in the kitchen or marveling at the rigidity of a skyscraper, chemical bonds are at work. The next time you glance at a piece of metal or a vibrant salt crystal, picture the invisible dance of electrons that gives these materials their form and function. The challenge of understanding chemical bonds is now transformed into a riveting exploration of forces, interactions, and patterns. Our journey reveals that what seems mysterious is actually a natural and elegant process. Visualize atoms as enthusiastic partners, each seeking connection to create something greater than the sum of their parts. Every bond, whether ionic, covalent, or metallic, plays a role in building the intricate tapestry of chemistry. As we wrap up, remember that the power of chemical bonds lies in their simplicity and elegance. They are the unseen connectors of the universe, making the complex world of chemistry accessible and fascinating. We have seen how atoms share, attract, or blend in a seamless symphony of forces. Embrace this knowledge and see how it transforms your perspective on everyday materials. Explore the fascinating world of chemical bonds and discover how they shape the universe.